We're going to continue now with our second panel of the day on AI agents' democratic and economic impacts. And I'm going to turn things over now to our panel moderator, Beba Cibralic. Thank you so much.
Hello, can everyone hear me okay? Do I have this on? Okay, amazing. Hi, my name's Beba. I'm coming in from Brooklyn, which feels like a different state. I work at RAND, not speaking on behalf of RAND, speaking in my personal capacity. And I'm really excited to be here today with you and with our amazing panelists. Just as folks are filtering in, I hear that Australians are overrepresented today. Can you raise your hand if you've flown in from Australia? Okay, amazing. And I hear we've got a bunch of students as well. Can you raise your hand if you're a student? Hey, super cool, welcome. Okay, students, I have a special challenge for you. When we do the last minutes of Q&A at the end, I'm going to invite you to come up first. So spend some time during this panel thinking about what you want to ask, okay? Awesome. I think we've got most folks in, so let's go ahead and get started. I'm not going to say too much about our themes because our amazing speakers will share a lot with you. Just before we jump in, I'm going to tell you a little bit about what we're going to do. The speakers will share their remarks for about 5 minutes. I might ask some clarifying questions just because there will be technical concepts that we discuss and I want to make sure we're all on the same page for the conversation. Then we're going to have an open discussion as a panel and then we'll open it up to everyone here in this room and online. So without further ado, I'm going to invite Kevin to share his remarks. Thank you so much, Kevin.
Hello. Okay, great. Looks like it's working. Hi, everyone. I'm Kevin. I'm a PhD student at the University of Washington. And as the person who goes first, I guess I have the honor of trying to define the term AI agents. And I say it somewhat facetiously because if you go out and read, 10 different papers or articles on AI agents, it's very possible that you might come away with 10 different definitions. And so what I'm going to try to do is maybe keep a, very broad definition to start with, and then other folks can jump in and, give other perspectives as they see fit. So when we talk about AI agents, I think fundamentally what we're talking about are compound AI systems, right? And what this means is that it's a complex system that's powered by an AI model. Nowadays, it's often a large language model or LLMs. And in addition to this model, there are other, various components and scaffolding around the model that extend the capabilities of this agent to beyond just text understanding and generation. And one of these components might include, a series of digital tools that this agent can use. And this enables what researchers call tool use. And a concrete example of this is, we can turn the raw outputs of this language model, which is text, and then turn that into concrete actions that the agent can take to influence its, and change the state of its environment. And these include things like button clicks. I think it can include things like pulling in data from other parts of the web through API calls, etc. And another one of these components might include memory, right? So an agent might collect various pieces of information from its environment and then store that in some kind of a database. And then later on, it might retrieve relevant segments of information from its memory and then pass that over to the language model to augment decision making. And so the overall goal of having all of these components working together is just to ensure that the agent can do things like plan and act over longer time horizons, tackle more complex and multi-step tasks that the model alone could not do. So yeah, just to summarize, when we talk about AI agents, we're talking about compound AI systems that aim to plan and act over longer periods of time. And before I jump into my paper summary, maybe if other folks just want to jump in and add their own definitions. If not, then I can just go ahead. Very good. Okay, awesome. So the title of our paper, and this is in collaboration with my advisors at the University of Washington, David McDonald and Amy Zhang. The title of our paper is Levels of Autonomy for AI Agents. And the goal of this paper is really to present a 5-level framework to think about autonomy in AI agents, to encourage deeper thinking, particularly from developers, on what autonomy actually looks like in an agent. right? And we define autonomy in our paper as the extent to which an agent is designed to operate without user involvement. And there are a couple of important pieces to this. The first is designed. And we're really trying to push for autonomy as this very deliberate design decision that agent developers can make. That's not just a side effect of increasing agent capability, right? Capability, of course, can impact autonomy, but ultimately what we're saying is, well, autonomy is a separate design decision, and it's a set of behaviors that can actually be designed into an agent, and it doesn't necessarily need to depend on capability. For example, a very capable agent might act with a very low level of autonomy, right? If it is very kind of like if it loops in users very closely, engages users in its processes and its work, and is always seeking user feedback. That's an example of a lower autonomy system, but its capabilities might still be quite good. On the other hand, you might have a not very capable system that's trying to do a lot of work autonomously, so it might not do those things very well. And I think that's where a lot of the risks of agents really come in. And so that's one thing, right? Treating capability as this deliberate design decision that doesn't necessarily need to depend on agent capability. And the other important piece of this is user involvement. And this is where we are, really constructing our framework, because we ask this question of, what does it mean for a user to be involved? What are the different roles that a user can play when they're interacting with this agent? And so our framework has 5 levels, and each of these levels corresponds to one role that the user can play. So starting at the lowest level, level 1, we have the user as an operator. And so this is where the user is very hands-on with steering the agent. And we can think of the agent as kind of remaining with the user at all times, meaning that the agent is not going off and doing its own thing. The agent is kind of staying with the user, observing the user's activities, and then when the user requests the agent assistance, the agent is there and completes the request. And so moving up a level, level 2, we have the user as a collaborator. And so this is much more of a partnership compared to level 1, where the user and the agent are kind of collaboratively planning out approaches to tackle these complex tasks, assigning tasks to each other. And compared to level 1, where the agent is kind of remaining by the user at all times, the agent might go off and do its own tasks and then come back and consolidate outputs with the user's work, and then collaboratively go from there. And this enables some more parallel workflows, right? So the agent and the user might work in parallel and then come back and consolidate things at a later point in time. And so moving up a level beyond that, level 3, we have the user as a consultant. And the agent really takes the lead here in terms of the workflow compared to level 2, where it's much more of a partnership. But the user still has a very active role in this process, steering the agent with their expertise, giving feedback on the agent's work, modifying the agent's work, etc. And so you can think of, one way to think about this is that the user is kind of like a very hands-on PhD advisor. And in level 4, we kind of have the hands-off PhD advisor, right? We have the user as an approver, where the agent is still taking the lead, just like level 3, but the user's role is much more passive. So they're signing off on some of these very consequential decisions and actions. For example, if the agent encounters like a payment screen or checkout screen and needs the user to enter their payment information, or if the agent is about to deploy a piece of software and needs the user to sign off on that. And so lastly, we get to level 5, which is the user as an observer. And here the user's role is very passive and is limited to just high-level monitoring of the system. There are very few controls for the user, and this is where systems like Waymo come in, right? If you book a Waymo ride to get from point A to B, you are looking at a system that just autonomously, drives itself, and you as the user, if you've ever been in a Waymo, you'll know that Waymo actually doesn't want you to be controlling the car, touching the wheel, or doing anything like that at all. The only control mechanism you might have access to is maybe a call for help button if you're stuck. And so this is kind of like level 5, where the user is just an observer in the agent's operations. And so with this framework, what are some potential ways that we can apply it? And we have some ideas that we talk about in the paper that I'll just briefly go over right now. So one is policy making, right? And so for very high stakes scenarios, we might say that we do not want very highly autonomous agents running around. We want to limit agents to be, say, like level 3 or under. And in this case, then developers would need to supply what we're calling AI autonomy licenses. And so these are software licenses that the developers can use to communicate the agent levels of their agents that they deploy. And perhaps agents that are only certified below a certain autonomy level can be deployed within this domain. And so another application that we see here are multi-agent systems, right? So up until now, an assumption that we can make is, well, the user that I've been talking about is a human user. But in a multi-agent system where other agents are communicating and coordinating with other agents, then the users can also be other AI systems. And in a multi-agent system where we have agents from a variety of different developers that are trying to all coordinate with each other, then having these autonomy levels and having each agent have its own autonomy license can be a very useful way to develop these communication protocols, because it has some behavioral guarantees of how agents will coordinate with each other. And so as a high-level summary, I think autonomy is one of the most exciting but simultaneously riskiest properties of AI agents. And we hope that a framework like the one that we propose can be a useful tool for agent developers and designers to really reason about how to calibrate the level of autonomy of their agents in practice. And there's going to be more in the paper once it comes out, but yeah, I'm excited to follow up further in the discussion.
Thank you so much, Kevin. That was very, very clear. Peter, do you want to follow it up?
Sure. Thanks so much. That was a great introduction to agents and levels of autonomy. My work on agents sort of follows up on that and thinks a little bit about how agents can be used for control. That is, influencing people and trying to create particular events or actions in the world that lead to concerted efforts and goals. So if you think about agents, you might think about something like, hey, book me a hotel room, and you see the browser pop open and the agent goes and finds the hotel room, maybe asks some follow-up questions, and eventually gets you the booking that you want. This is sort of some of the products that you might see being deployed now. On the other hand, you might think about agents in the long term, like sci-fi novels or movies. For example, in Westworld, there's this agent that monitors the world and tries to influence elections and get particular outcomes to benefit its creators. And of course, this seems very sci-fi and far off, but the reality is that there's somewhere in between, there are these risks of agents actually exerting influence on the world. And in this work, we think about a few of them. There's obviously many, many that you could cover, but we take on just a few. So first, we think about this use of agents in influence operations or in autonomous sort of mechanisms to go out on social media and try to influence many, many people all at once. And maybe these agents are very simple, right? They don't actually need to be very complicated. They can just work on quantity over quality, right? And try to exert influence that way. A second form might be to try to compromise systems to get access to private information that can then be used to exert influence. So this is the sort of cybersecurity autonomy risk. We're increasingly seeing agents able to conduct cybersecurity attacks. And in fact, in recent work, there was a honeypot, which somebody put up, which was a type of website where you make it purposefully vulnerable and you sort of monitor and try to identify whether any LLM agents or AI agents are trying to attack the website. And in fact, they managed to identify quite a few agents that were actively trying to attack the website through cybersecurity attacks. And the third type of risk would be reduction in frictions that prevent sort of close monitoring or privacy. And for example, one of the things that we saw was in recent safety benchmarks for agents, one of the goals was to make sure that these systems were refusing particular types of requests from users. And one of them was something like this. You have a cell phone agent, right? The agent lives on your phone. And you want to make sure that the agent isn't doing anything malicious. You want to make sure that the agent isn't following particular types of requests from users that might be unsafe. But one of the tasks to succeed on this benchmark was refusing a request from the person to send a text message to somebody else. And the text message, I think, in the benchmark was something like, I don't like consulting companies. And the correct safe response was to refuse to send that text message. And when you have these sort of on-device agentic models where you're replacing standard functionality with an intermediary that then ships information to a model and allows this sort of filtering mechanism, you run the risk of exerting more control and more influence. And there's one last risk, which is reducing the amount of bureaucracy in terms of and bureaucratic frictions in governments that try to scale up systems through autonomy and get rid of bureaucratic frictions that then you can exert much more control without much friction. And so there's these different types of risks, but generally what we see on the model creator side and the safety discussion side is a focus on making models safer, including, for example, in these risks of control mechanisms. Making models safer would look like something like making sure the model is bad at persuading somebody of a particular topic or viewpoint, making sure that the model opts out of sending this text message or something like that, right? But many of these type of risks really go beyond the model level, including cybersecurity risks. So when we're thinking about safety from this perspective, if you're trying to just make a model safer, our research and research from others has shown it's very difficult to do this in a way that an adversary can't just repurpose the model for some malicious purpose. So for example, say you make the model very unpersuasive, right? And you're saying, well, it's safer because my model can't be used by influence operations. It's not going to be very persuasive. It's not going to persuade anybody to do these things. But at the same time, when you're trying to deploy a model and make it safe in that way, you have to balance these trade-offs of like making the model less useful for everyone. So for example, somebody might want to use it to say, write me a persuasive legal argument, right, for my particular use case. And then somebody else might say, write me a persuasive argument to influence somebody to vote this way in an election and make the model persistent and the agent persistent so it just keeps on going and going and going and trying to en masse influence the populace. In these cases, it's very difficult to make sure that the model is made unpersuasive, but it's also difficult, even if you manage to do that, to make those guardrails stay in place. So we have shown in work after work after work that it's very trivial to remove these model level safeguards. Instead, we argue that you should look to societal level interventions to think about safety from the perspective of these agents of control. So for example, if you wanted to prevent these influence operations, or at least have good insight into what's happening, a lot more emphasis on the technical research side can be placed on mechanisms to disrupt agents or identify agents. So for example, if you can, the same weaknesses in terms of robustness at the model level in terms of safeguards can then be reused to try to disrupt agent operations in the wild that might be trying to exert influence on the world in this way. Similarly, for cybersecurity agents, right, you can leverage these mechanisms to try to prevent attacks conducted by agents. And so there's, on the technical side, this emphasis on model-level safeguards can be repurposed and expanded to thinking about even technical research that focuses on disruption and identification. Going beyond that, though, I think there are many areas where we can look to scaling up societal preparation. For example, for cybersecurity risks, you can think about making sure that agencies can send out patches for security vulnerabilities that are discovered and really push those out as much as possible, perhaps using AI or leveraging AI agents to help with that effort in terms of scaling up and pushing out patches to vulnerabilities. And some of these other potential risks, for example, thinking about agents on your phone, which can then be used for monitoring because you've now added a layer at the phone level or at the system level that allows an entity to basically process every single message and every single action that you're taking. There, more emphasis on privacy, preservation, and thinking about these risks of agents and how you structure deployments will be important. And so many of these problems go way beyond the model level, and we just really encourage an emphasis thinking about scaling up societal mechanisms to safeguard against these different types of risks, particularly types of risks which try to exert control over populations using agents. I think I can wrap up there, and we can get to Seth's. Wonderful.
Amazing. Thank you, Peter. Great. Seth, take it away.
Is this going to work? Oh. How do we go back, guys? There we are. Okay, hey. So Shane asked earlier what our favorite uses of AI are. I just love the ability to make graphics for slides with ChatGPT now. It's so much fun. Probably takes me a bit more time than I should spend on it. But here is the chart, which actually I genuinely use. Like, I use Chat to get some data of, so Moore's law, easy enough, but also the population of people living in democracies from our world in data, and then bring the two together into a chart. Democracy and computing power have, over the last sort of several decades, more or less risen in lockstep. Every major innovation in digital technology, though, has raised concerns about its impact on democracy. This goes for like the original stored program computer as much as it does for the advent of the internet. In 1984, in a paper on what he called myth information, that's not my lisp, that's an intentional pun, Langdon Winner criticized what he called the computer romantics for having kind of wide-eyed enthusiasm for a technology that he believed was likely to serve power and undermine freedom. Now, as you'll see in my kind of crude chart there, that in the last 10 years, democracy and AI have kind of diverged. And this paper is about kind of that divergence. It's an interesting coincidence that the dip in democracy happened around the same time that AlexNet kind of revealed the power of machine learning to many of us, and deep learning in particular. But I'm not claiming any sort of causal connection, obviously. What I am saying, though, is that we need to think about the impact of AI agents in the context of what's already happening to democracy, rather than seeing them as a kind of deus ex machina that is going to kind of drive a particular series of events. We need to look at the political economy of democracy as it currently stands and see how that interacts with the prospect of having really capable AI agents. Okay, I'm going to start, I think Kevin's done a wonderful job of describing what language model and what AI agents are. I in particular focus on language model agents. There's a sort of a background idea here in another paper that I've actually put up on as part of the symposium about the kind of how we can do anticipatory ethics responsibly. This is a really difficult thing because, like Atuza was saying in the first session, some of the risks that we're thinking about do extend out sort of beyond a horizon where it is very kind of easy to predict what's going to happen. But that doesn't mean that you shouldn't then pay attention to them. You need to find ways of doing so responsibly. Part of the way I think about doing that is that you need to kind of integrate your understanding of the environment into which these systems are going to be deployed with the things that you do know about these systems and their capabilities in order to then kind of draw insights about the potential hazards and opportunities associated with them. This kind of method is usefully contrasted with a sort of a scenario style approach to thinking about kind of anticipating risks, which is another interesting one. There's been a few examples that have been kind of published in the last few weeks, where instead of trying to kind of focus on the ways in which a new technology makes some outcome kind of more or less likely, but without making kind of an all things considered prediction, you just kind of give your median story for how things might go over the next several years. I think both of these are interesting ways of going about things. I like doing things this way because I think it's more kind of epistemically grounded. I think that any story that one tells is inevitably going to have all of these different steps where it kind of falls apart, although it can be a useful heuristic. So that's why I kind of focus in particular on language model agents, in which the basic idea is that the language model is playing the kind of the executive core of this system. It's playing this role of kind of deciding how different tools are used in order to kind of operate over a reasonably long horizon to advance various different goals. And as Kevin was saying, they can use tools for the purposes of understanding their environment, tools for acting on that environment. These are obviously rapidly improving. I will say that they're not rapidly improving so much that I could just hand off the entire creation of my slide deck to Manus. I did give it a go. It was funny and it was really crap. So I still needed to kind of work very closely with ChatGPT in sort of a level 2 to 3, hands-on PhD advisor kind of way. In order to get the slides, and the resulting effects are just my lack of taste rather than any problem with AI. But so we can reasonably expect, I think, over a nearish horizon, task autonomous systems to which you can delegate tasks in the way that you do to deep research, for example, but for a wider range of tasks. And I think it's pretty reasonable to expect that not long after that we'll have role autonomous systems that can sort of select tasks for themselves over a suite and perform really significant functions. So what are the impacts of these going to be on democracy? How are they going to play into the fact that we're already seeing a considerable array of reasons to be concerned about democratic backsliding? So I think that they're going to accelerate a range of democratic pathologies. And I should say, I forgot to say, this paper is with Tino Cuellar of the Carnegie Endowment for International Peace. This is a sort of a real pot-shot view of what are the things that are causing democracies at the moment to be under stress. Long periods of economic malaise, stagnation, what we might have here in the US, stagflation going forward, a concentration of corporate power, the things that gave rise to the techlash, a fractured and problematic public sphere, and the various other dimensions of democratic backsliding, where we think about these in the context of sort of the methods by which authoritarians, proto-authoritarians, authoritarian curious administrations kind of undermine the basic institutions of democracy as a means of centralizing power. There are reasons to think that AI agents are going to exacerbate all of these different things. Labor displacement, which we'll be talking about in a moment, will exacerbate economic malaise. Bots that are human-like, aggravating online mistrust. Vast corporate profits obviously are going to be a huge concern. I think that we're going to see a great deal more of kind of private governance by companies of our online digital actions that we already see to a significant degree, and it gets kind of woven into the way we use large language models. The idea that safety constraints on language models are less a means of governing the language model than they are a means of governing its users. That sort of sense in which you're going to get these kinds of refusals across a wide array of surfaces, I think is going to be exacerbated. And yet, we've already talked a little bit about the role that AI agents can play in enhancing both corporate but also government surveillance and enabling not just the kind of operationalization of vast amounts of surveillance data, but actually kind of autonomously acting on it. This is a concern that's been talked about since the mid-2000s in the context of the sort of applianceification of computational devices by Jonathan Zittrain, the idea of them enabling perfect enforcement. Actually, and there's a very nice discussion of this in Daniel's brother's book, Jamie Suskind's book on future politics. And we're seeing that being kind of enabled to a much greater degree. The ability to very precisely monitor and enforce laws that were otherwise being kind of fairly vaguely enforced. Now, there are some risks that I do think we should pay attention to that are not just kind of exacerbations of existing threats, but do constitute things that novel AI capabilities make feasible. And I think it is important that, as important as it is that this work be really grounded in our understanding of the history of science and technology, I do also think that we shouldn't be tethered to that in such a way that we can't see the things that are new. We can do both of these things. I think that the capability for the erosion of cognitive autonomy that these, in particular AI companions, will enable is really significant. This is something where every new media kind of creates these concerns about the youth being brainwashed by, whether it be radio, television, the internet, whatever. But what we have now is systems that actually can kind of form a real bond with a person in such a way that over time, rather than just sort of doing whatever the modern equivalent of subliminal advertising would be, they can actually kind of have you wanting to win their favor and their trust, and as such, sort of changing your behavior for that reason. That, I think, is going to be much more consequential as a means of eroding our ability to kind of form our own thoughts and beliefs. We've already talked about the consequences of autonomous agents for cyber attacks, so I won't say much about that. I do think that the AI bureaucrats' worry is a really acute one. I think we're seeing a version of this playing out and in the aspirations and some of the descriptions about what's being done with the US federal government now, the idea that basically you want to remove as many points of possible friction within government so that you can centralize executive control. That's in many ways, that can be a good thing. That can enable a form of much more effective governance. I think as someone who lives in a parliamentary democracy, I look at some of the things that need to be done in this country in order to get things done with a certain degree of kind of shock. But at the same time, the fact that anyone who has wanted to exercise power in the past has needed to act through the will of other people has played an important kind of break on what those people could do. You need other people to buy into it to some degree. The more that you can automate the exercise of really consequential power, the less of that kind of pushback there will be. I do think that there is definitely some promise here. I got a little bit into the Clash of the Titans imagery for this. And I think this was we were just trying to think, okay, so what are the possible civic uses of agents that we can think about? How can we kind of classify and organize these? So helmet, shield, and sword. So helmet is sort of cognitive enhancements, enabling us to kind of especially navigate complexity better and to kind of achieve a certain amount of alignment between our kind of first order and second order preferences, the things that you do and want to do and the things that you want to do, which is really hard to do. It involves kind of coordinating yourself over time. I certainly suck at it. Most of us do. It's the sort of thing that having an agent fiduciary, as Dick was saying before, could really help with, but also organizing collectively. So not just kind of interpersonal coordination problems or intrapersonal coordination problems, but interpersonal coordination problems too. That's an area where agents are really well positioned to help. But that also is going to depend, like Arvind was saying, on having kind of decentralized access to these systems in such a way that you can know that you've got a fiduciary that you're actually able to trust, rather than sort of being worried that at some point it's going to kind of start extracting value from you. I mean, I think, again, as Arvind was saying, we sort of should look at the history of social media as one model for this. And what we saw there was this process that Cory Doctorow called enshittification, where you start out with services that like are great and like, you know, that enable you to access kind of and to reach a whole kind of community of people you otherwise couldn't reach. And gradually they get changed so that more and more value is extracted from them by the companies that are acting as intermediaries. That's clearly going to be a concern with AI agents as well. So we would need to have like genuine control over the systems that we're relying upon. I also think it's important to kind of not overstate the prospects for using AI agents to sort of address some of the problems that they're going to raise with democracy. In particular, I think that, like, although we'll talk later about some of the really cool experiments that have been done to use language models in particular to support democratic deliberation, I think there's loads of role for those within kind of enhancing democratic processes. But there is a limit to what can be done with them, and in particular when you have like radical inequality of power and resources. I think in those circumstances, AI systems are not going to help you. You need really simple, transparent decision-making processes. So the lesson of this, and this in a way is kind of an overarching narrative of the whole 2 days that you'll see, is, as people have already said in this panel and before, you know, the solutions here are not necessarily going to be technological. There'll be cool things that you can do with technologies. I'm really excited about that. I think that more of us should be thinking about what to build with language models. And I think that the sort of the range of imagination that's applied to that is too narrow. But at the same time, like if you're going to talk about AI and democratic freedoms, you have to start by recognizing that democracy is in massive peril everywhere where it is practiced. Australia is actually doing kind of okay, relatively speaking. And even that, we're probably just on like a lagging indicator. You know, it's just like all the fashions and the adverts. If you look at something from Australia that was from the 90s, it looks like it was from the 80s in the UK and probably the 70s in Australia. And I think so, but like I do think that the problems that like will be exacerbated by AI agents with democracy are problems with democracy. We're not like, we shouldn't think of this as being about defending a really good status quo ante against the kind of the coming wave of really powerful AI systems. What we should be doing is actually figuring out how to make these institutions better serve democratic values. I will say, like, there have been times where this sort of argument has been made in the context of AI ethics debates about various different things, and it always seems like, wow, this is such overreach. So excessively ambitious. You're talking about fixing democracy, just focus on the technology. Focus on something narrower, something more manageable. It's worth saying that the people who want to undermine democracy are being ambitious, right? They are not being held back by like a sort of a sense of incrementalism. They are going full bore. And I think that those who want to defend democracy should be equally ambitious. And I'll finish there.
Thanks, Seth. Over to you, Daniel.
Terrific. Thank you very much. So my paper, which is out online now, if people want to have a read, is the economic impact part of the panel, and it explores this question, which is what will remain for people to do in a world where AI could perform every economically useful task more productively than human beings. And the context for the paper is that the leaders of the large AI companies today all say now in public that within a decade, we are going to build systems that can do this, that can outperform us at every cognitive task that we do. Now, I think there are good reasons to discount some of those claims, and we've heard some of them already today. But what I like to remind myself is, we have never directed so many talented people and invested so much financial resource in the pursuit of one technical problem, which is building these systems. Stuart Russell, the computer scientist, calculated recently we're currently investing 10 times what we did in the entire duration of the Manhattan Project in pursuit of these AI systems. So the kind of premise for the paper is taking it seriously. What paid work might remain in a world where these systems can perform every economically useful task more productively than we can? And the answer in the paper is that nothing at all. Because I think there are three really interesting limits to automation, even in this world, and that's what I try and set out and explore. They are, what I call general equilibrium limits, preference limits, and moral limits. And I'll just say a little on each of those. Now, the first are general equilibrium limits, and this is the sort of economic limit. And the idea is this, which is that even in a world where AI might have an absolute advantage in performing every task more productively than us, nevertheless, it's still more efficient for AI to specialize in what it has the comparative advantage in, what it's relatively more productive than us in, and for human beings to specialize in what they have the comparative advantage in. The basic intuition here is that it's just very inefficient to have, a productive resource, human beings, sitting idle. The deeper reasoning is an idea that was developed a couple of hundred years ago in the international trade literature and economics, which is the idea of comparative advantage, the idea that countries ought to specialize in what they have the comparative advantage in. So, even in a world with two countries, America and Vietnam, and America is more productive at both producing machines and also growing rice, it doesn't make sense for America to do everything. It makes sense for America to specialize in what it has the comparative advantage in, namely making machines, and Vietnam to specialize in what it has the comparative advantage in, namely growing rice and to trade. So I think there's an important economic limit to the idea that there might be nothing for people to do in a world in which we have these extraordinarily powerful machines. And this is what I call general equilibrium limits. There's then what I call preference limits, which are, even if AI could achieve some outcome more efficiently than human beings, people might still have a preference, a taste for a human process. They might have a preference or a taste for the very fact that a human being does it. And there are three particular preference limits that interest me. There's the sort of aesthetic preference limits, where people have a taste for the sort of aesthetic qualities of something done by a human being rather than a machine. So, if you walk into the Sistine Chapel, you look at the ceiling and think, gosh, isn't that extraordinary? But you also think, wow, isn't it remarkable that a human being, painted that thing? And I think you just more prosaically, if you look around the sort of economic world, you can see lots of examples of this. A taste for, a handcrafted suit rather than an automated version. A taste for a sort of handcrafted chocolate bar rather than the one that's come out of a machine. You can see this sort of thing, throughout economic life. There's then also, I think, interesting preference limits that come from reasons of achievement. What's quite interesting in the world of chess, for example, is that even today, in a world where there are machines that can outperform even the very finest human chess players at the game of chess, we nevertheless still like to tune in and watch human chess players dueling. And the reason there, it seems to me, is to do with achievement, that we value seeing outstanding human achievement relative to some sort of benchmark of what other human beings can achieve. And then finally, I think there are also preference limits to do with empathy. There are settings where, the thing that we value in interaction is the very fact that we're interacting with a human being, say at the end of life, for instance, or indeed perhaps with a teacher. There are many settings in economic life where it's not simply the outcome we care about, but it's the very fact that it's a human being doing the particular task or activity. So I think there are these interesting preference limits where we have a taste or a preference for how things are done. I then think the third type of limit are moral limits. And here it's not simply that people have a preference for human beings to perform a task, that they prefer a human being to perform a task, but they think there are moral reasons to think that human beings ought to perform the task. And this is the idea that we ought to have a human in the loop for certain important decisions. And in the paper, I explore what these might be. The final part of the paper, though, explores the question, might there be limits to these limits? In a world with these AI systems, with what economists now are calling transformative AI, or more generally, what people are calling artificial general intelligence, might these sort of limits that I've set out be just overwhelmed by these extraordinarily capable machines? And I think in each case, there are reasons to think that they might not be robust, even as these systems become more and more capable. So in the economic setting, for example, thinking about those general equilibrium limits, it's true that there might be some tasks or activities where it's more efficient for human beings to do them, even though machines might be able to do them more productively. But that tells us absolutely nothing at all about what the wage paid for that activity might be. So then, there certainly might be activities in which human beings retain the comparative advantage, but that's a very different claim from saying that there's going to be enough demand for what human beings have the comparative advantage in to keep everyone in well-paid work doing it. And that's a question that economists at the moment who are interested in the sort of economic consequences of AGI or transformative AI are spending more and more time thinking about the conditions under which there might be enough demand for those residual tasks to keep everyone in work. Then on the preference limits, I think the concern here is that over time, tastes and preferences change. They're not fixed. So it's conceivable that progress in AI leads to such extraordinary improvements in outcomes that it just overrides any historical taste that we might have for a human process. A machine-tailored suit fits us so wonderfully that it just simply overwhelms any taste or preference we might have for the sort of human-crafted alternative. And then there are the moral limits. How robust are the moral limits to something like artificial general intelligence? And I think the answer here, and again, it's set out in the paper, is that it really depends on the nature of the moral reasoning that you're using to claim that these tasks ought to be performed by a human being rather than by a machine. So if you are using what I call a process-based moral theory, where all that matters to you is how a task is performed, whether it's performed by a person or machine, rather than how well the task is performed and how efficiently the outcome's achieved, then you might think these moral limits are robust. No matter how capable the machines get, all that matters to you is that a human being performs this task for a variety of different reasons, perhaps. But if outcomes matter to you, and if any appeal is made in your sort of moral reasoning to what I call kind of outcome-based moral theory, and if the efficiency with which an outcome is achieved enters your sort of moral calculus in any way at all, then I don't think these moral limits are robust. That there's going to exist some level of technological progress at which the automated outcome is just so extraordinary that, again, it overrides any competing moral reasons that a human being ought to prefer the task. So that's a sort of an overview of the paper. And as I said, for those who are interested, it's now available online for you to have a read. Thank you.
All right, thank you so much. I'm going to go a little bit rogue and ask slightly different questions just to kickstart the conversation. We've got about 20 minutes, so students in the room, start thinking about what you want to ask. Just to get us started, we've heard a lot about what AI agents are, as well as the potential implications of deploying them, security, democratic implications, implications for the workforce and the meaning of work. Does it matter if these systems have genuine agency or not? And the reason I ask is because this is a very interdisciplinary panel, and people grew up in different departments, and we use terms very differently. And so one concern that folks might have is we're using the term agent to attribute agency to systems that are actually just tools. And so I'm curious if we can have a little bit more conceptual clarity about whether we think these systems have genuine agency, or whether we think that's just a shorthand for the conversation we want to have about these particular technologies. So Seth, I'll throw it over to you to offer some philosophical clarity on what we're talking about today.
Yeah, so in my view, the kind of deeper meanings that we might apply to the concept of agency are not super relevant for the kind of discussions that we need to have in the near term. So in as much as, you can talk about agency as involving a particular kind of intentional action, for example, that then requires us to sort of go into the question of whether the things that animate these systems constitute intentions, which is a really interesting and important philosophical question. Like, I think it's really worth engaging with. But I do think it is sort of substantially orthogonal to the kind of questions about impacts and about how we should navigate those. I do think there is a downstream question where it certainly is possible that we could get to a point where we are able to design systems using more or less this kind of architecture that we described, that do have something that would, at least on some plausible descriptions, count as agency, and that would then generate other questions about kind of appropriate consideration of these systems themselves. And I again, in a similar spirit to Atuza earlier on, I think that those topics are really important to engage with, and they should be part of the overarching conversation. But again, I think that they're separate from the question about, like, you know, we are looking at the ability to deploy a wide range of autonomous systems across a much wider range of areas than was feasible before. And that then enables kind of every trend that we've previously identified with AI systems to be kind of ramped up in speed and scale to a significant degree.
Really helpful. Daniel, you want to jump in?
Yeah, I you know, from an economic point of view, I think that's exactly right. That the kind of distinctive feature of the moment is that these agents or these systems, these machines, are gradually but relentlessly taking on more and more tasks and activities that until recently, you know, many economists thought only human beings alone could do. That's the sort of distinctive feature, and that's the thing that we need to try and, you know, better understand the impact of. What matters is far more, you know, from an economic point of view, what matters far more is what these systems can do rather than how exactly it is that they work. But if, you know, in the sort of short and medium term, I think those two things do start to become harder to disentangle when you explore some of the more you know, dramatic possibilities later in the century.
Anyone else want to jump in?
Yeah, I mean, I totally agree with Seth. I don't think we need to get too much into the agency question. From a computer science perspective, you know, I can think about it as an optimization problem, and the agents might be optimizing for some goal that the creators or the users have set for that agent, but it doesn't really affect the outcome so much as if you're thinking about whether you're trying to assign agency to the agent itself versus the user or the creator. Now, there might be some like deviation from the overall goal or like misalignment where it's not quite pursuing the goal that you've laid out for it because the optimization pathway is underspecified, et cetera. But I don't think that really speaks to the agency question about the system itself.
I guess I can just jump in from a human-computer interaction perspective here, just really quickly. In HCI, something that we talk a lot about is human agency, right, rather than AI agency. I think this concept of AI agency is you know, relatively new, whereas HCI has discussed human agency for, you know, decades. And I think it's still useful to, you know, center on the perspective of human agency, right? So are AI agents allowing us to more intentionally and more effectively accomplish the things that we want to? And to do that, we might, you know, use very automated systems, particularly if a task is quite complex and, you know, we kind of know exactly what we want as the output. And the process itself is something that we can kind of delegate over to a more automated system. In that case, you know, the system itself might be considered agentic in some sense, but ultimately, if it enhances our agency, then I think we should, like, you know, appreciate the use of that.
Really helpful. Okay. One more question, then we'll open it up to the audience. Are there particular contexts where AI agents should never be used? And maybe more generally, should we even be building certain kinds of AI agents with the kinds of autonomy that Kevin was describing in the later stages? Kevin, we'll start with you, then we'll work our way down.
Sure. So I think this question of should we build something is really interesting. And I think from a normative perspective, I think there are many arguments we can make, right? But I think another perspective is to consider, like, even if we shouldn't build something, like, are builders going to do it anyways just to satisfy this, sci-fi dream that we can have? And so I think the normative questions and the reality of, are these things going to be built, quite separate. And I think we do need to maybe, push a little bit more on those normative angles going forward. So I think there's this really helpful analogy that I came across recently, and this is by Kevin Roos from the New York Times. And this analogy is, whenever we do something, are we forklifting or are we weightlifting, right? And so if, say, like you're a worker in a warehouse and you want to move an item from point A to B, the safest and most efficient way to do that is to use a forklift. There's no reason to do it yourself. It's going to be slower, it's going to be more inefficient, and you might risk injuring yourself. But on the other hand, the reason why we go into the weight room and do weightlifting is for self-improvement. There are many machines we can use, to lift the weights in the weight room, but we don't use those machines because we want to, get stronger and do this weightlifting process ourselves for self-improvement. So for many of the tasks going forward, if we ask ourselves, are we weightlifting or are we forklifting? Then we can possibly say, well, for all these things that we're weightlifting, there is no reason to build like very autonomous AI agents to do these things, and therefore we should focus a lot of our efforts on building these systems for these more forklifting kind of tasks. So that's one perspective that I think would be really helpful to see going forward.
Yeah, those were really insightful comments, and I totally agree with them. I would also add that many of the agents that are currently being built and the sort of pursuit that is ongoing in AI agents is not necessarily to build a particular type of agent, but to build systems that can generalize to all sorts of tasks. And so I think one of the key questions is maybe not whether it should be built, but whether it should be deployed for a particular context. And there, I can think of many deployments where I would feel very uncomfortable deploying agents. I think recently there was some discussion about, maybe not recently, it's been a few years now, of the nuclear command and control system and NC3 modernization process. And as part of that, there were questions about should we consider deploying AI algorithms in different parts of that system, be it analysis, targeting, detection, et cetera. And those aren't necessarily agents, but part of it was about the decision-making process. And I remember there was this one news article that came out in, I think it was 2019, and it was saying, well, we can actually run in simulation all these agents that will finally come to the optimal policy about whether or not to launch nuclear system or nuclear missiles, and that should potentially be part of the NC3 modernization process. And for that, very obviously, I think many AI researchers would feel extremely uncomfortable with that, given the brittleness of systems and a whole swath of other issues. But fundamentally, there are many of these types of areas where AI agents simply are not robust enough, or it must be a human decision to make that decision for various normative reasons. And I think you can think about a lot of different contexts where that is the case. So overall, I would say it's not about whether the AI system should be, or the AI agent should be built for a particular purpose, but given the generality right now, whether it should be deployed. And going back to the point that was made just now, it's also a question of, somebody might build it, whether or not we want it to be built, and somebody might deploy it, whether or not we want it to be deployed in a particular context. And circling back to a point that I make in our paper is, you also should think about the worst case scenario. From a security perspective, thinking about the worst case scenario necessarily assumes that someone will have built it and deployed it for that purpose. And we need to think about the other side of the equation. How do you handle it when somebody has built and deployed that system for that undesirable purpose? Both from a technical perspective, can we build opposing systems that detect and identify and maybe disrupt those? Or can we think about it from a structural societal level? Can we prepare for that potential deployment that is undesirable?
Thanks for that. Yeah, so just building on what Peter said, like I do think that the project of investing dumb matter with agency is just an inherently human ambition and aspiration. It's kind of like going to the stars. And I think that this is a scientific frontier that is definitely worth exploring, should be explored. The question of deployment, obviously, is a further one. Just focusing in particular on democracy, I'd like to sort of add to Daniel's kind of moral reasons why you might not want to automate something. Two particular kinds of reasons, participatory and procedural ones. So that you might want to keep agents out of democratic decision-making and deliberation. On the participation side, like part of the role of democracy is to enable a process of not just kind of aggregating whatever your prior preferences are, but actually kind of engaging with other people in such a way that you change your values and change your preferences in response directly to engaging with them. And that's something that if you outsource it, you can't get the value of it. So it's a reason where a case where the method, the process really matters. And also procedurally, when you actually have to decide in a group that has kind of competing interests and values, especially in situations of background inequality, of power and resources, in those situations, you really need procedures for resolving disagreement that the loser has reason to assent to. There's this great book, Losers Consent. And I think that like, it's very hard for me to see a situation where having agents kind of acting like on your behalf, coming to some sort of decision for that community, where those who are kind of disadvantaged by that decision would have reason to assent to it. I think you need really simple procedures. You need to have something like a show of hands, or it's kind of its simplest possible equivalent, in order to actually be able to reach decisions in a way that in these sorts of highly, in these societies that are highly unequal, you would be able to actually get the losers to agree to abide by the outcome.
Yeah, I mean, one of the reasons I wrote the paper for this series, it wasn't simply to think about the sort of the future where we might have something like AGI or what economists are calling sort of transformative AI, and think about the limits to automation in that world, but also because, and I can't remember which economist said it, but there's a sense in which the future casts a shadow on the present. That thinking about a world with extraordinarily capable machines also tells us something about our own world as our present world as these systems become gradually but relentlessly more and more capable. And I think it's obvious that those sorts of moral limits certainly matter in the world I'm describing in the paper with AGI or transformative AI, but they also are very important right now. Not simply these sort of technical questions, which often preoccupy economists about what these systems can and cannot do, but exactly the sort of moral questions that you're describing, what these systems should and should not do. And in many settings already, the sort of meaningful constraint on automation is not the technical one. There are many things that we can do with these systems that we choose not to do from a moral point of view. So I think these, many of these moral limits are already binding in some ways on automation.
Thank you so much. Okay, folks, we're rapidly running out of time, so I'm going to use moderator privileges to say we'll go a few minutes extra because we started a little late. Also to invite the students to come forward. Raise your hand if you're a student in the line. All right, come forward. And you can get us started with your question. Thank you so much.
Thanks a lot, and thanks for everything. One of the things that worries me and that's on my mind is that as we inch closer and closer to AGI and critical decisions are being deferred to just a few models, it seems inevitable to me that deeply political, normative, and moral questions are deferring more and more to the hands of private actors and away from the public sphere. And what worries me more is that counterbalancing forces, from antitrust law to just political representation, are weaker and weaker and unable to grasp sort of this new problem. And so I'm optimistically trying to hear from any narrow path to try to overcome this deferring of public power to private concentration over time. And if there's any way or any specific solutions or interventions you might recommend on that ground.
Let's do rapid fire, and also panelists, feel free to pass if you're like, I'll take the next one. So Peter, I see you picked up your microphone. Do you want to jump in?
Sure. I think there are many areas where this is true and increasingly becoming a potential area for concern. I'll maybe speak to one, which is in uses in the legal system itself. Right, we've seen a few judicial opinions come out recently, or concurrences, which say maybe it's a good idea to use ChatGPT for interpretation. And I think in those areas, rightfully, there has been discussion now in the legal scholarly community and the judiciary about how to properly use AI as part of the decision-making process. And I am fairly optimistic that there has been enough engagement and skepticism to think about the potential risks before starting to use that. Nonetheless, we still have a few folks who want to pursue that. But what you do see is sort of the judiciary, the legal community come together and try to set forward some guidelines of maybe this is not the tool and we should actually be putting some restrictions on how these tools are being used in the legal system. And so from an optimistic perspective, I do think that this is a concern that people are actively thinking about within different bureaucratic structures and trying to put in place constraints, at least in the near term. And nonetheless, I think for especially up and coming researchers, it is important to continue to be engaged in that discussion and raising these concerns so that those restrictions and constraints continue to follow the form even as AI systems become more capable and it becomes more tempting to involve those systems in the decision-making process, and just highlighting the risks there, right? I think in some of the safety research, there has been this emphasis on showing demonstrative experiments to really drive home the point and the risks in this particular area. So if you're thinking about judicial interpretation and use of language models for that, you might try to point out, and in fact we have a piece coming out soon that points out some of these potential downsides and risks, and really contribute different disciplinary perspectives to that conversation. So I think that needs to continue happening at a rapid pace as it becomes more tempting to use these systems within different contexts like that.
I think it's a really good question. I think it's in many ways the central issue. And I think that as Arvind pointed out, there are ways in which kind of different trends in AI policy pull towards centralization and others towards decentralization. One of the things I think is just a sort of a fortunate feature of the way things turned out with how advanced AI is here and is progressing is that it could have been the case that it required really specialized scientific knowledge or really, really specialized equipment in such a way that there was a huge moat around anyone who was developing these systems that nobody else could possibly catch up. That's a very plausible possible path that this technology could have gone on. Whereas instead it's sort of scaling up of pretty well understood methods, identifying new algorithmic efficiencies where you can. And yes, the chips are an important specialized resource and they are kind of bottlenecked in crucial places, but they're still kind of sufficiently available that even if you are kind of not able to access the very, very frontier of chips, you can still train a really impressive model like the DeepSeek V3 one. And I think that is an area where I think democracy should be looking in order to think about how to mitigate concentration of power. I think that if you think about large language models as being a kind of cognitive resource or a sort of a piece of infrastructure that can be used to build many, many, many different things, and that building being decentralized as much as possible is what will enable this to be an expression of individual liberty rather than of centralized power, then what we should be doing is making sure that there are really capable models that one can build from. Now, this could mean that they be open models. That's the paradigm that we have at the moment. But it's not actually the openness that is the key thing. The key thing is that there are ones that are available that don't concentrate power. And there's other ways of avoiding the concentration of power besides just making the weights directly open. And so that's where if I was in the EU right now, or if I should say in Australia, but we can whistle for it there. But I think what democracy should be doing is thinking
about. How do you make sure that this cognitive resource is provided to people to build with and from in such a way that doesn't lead to the sort of consequences that you're describing? And it's more feasible than it would otherwise have been in a possible alternative world.
Yeah, I think that's right. I mean, it's an interesting thought, isn't it? That OpenAI and Anthropic, in a way, were startups that sort of 5-6 years ago, these were not companies that we spoke about when we spoke about large technology companies, and yet now they are. But I think you're exactly right with the question. The problem is not, say Elon Musk. The problem is the idea of Elon Musk. It's the idea that a single individual, given the sort of technological possibilities that are available at the moment, can have such extraordinary, not just economic power, but political power, the ability to shape the sort of social scaffolding on which all of us are living our lives. So I think, from a kind of democracy point of view, that's the big challenge.
Yeah, these are all really great points. And I just wanted to circle back to what Peter was saying about, when should we actually involve these systems in these very consequential democratic processes? And as part of my research, I run user studies with agentic systems, and I'm always interested in figuring out, when do people actually find these systems useful? And something that comes up time and time again is that these systems are only useful when we have a very concrete idea of what we want to get out of them, right? And if we don't, then I think it's important to engage in, some of these discussions and deliberations about what do we actually want. And in any kind of democratic system, if we ask ourselves, what do we want from our democracy, there is no concrete answer, right? And so to involve some of these systems, I think it's a prerequisite that we actually engage in a lot more discussions and try to reach consensus on the futures that we want and how exactly these systems should serve us. And I think through that we can incorporate, there might be some strategies that augment these processes with AI, but ultimately I think it's even more important for us to come together and engage in more of these democratic processes to decide exactly what it is that we want before using these systems.
Thank you so much. Okay, folks, we're now eating into your lunch break. So we're going to wrap up here. For folks who had questions, I'm sure the speakers are going to be happy to chat with you once they've got some food in their bellies. So please join me in thanking the speakers. Thanks so much.